What's up, brothers and sisters? I'm your host, your brother, your professor, Mr. O'Neil Barnaby, founder and director of the Black Math Academy, here with another video showing you what intelligent black society is all about. All right, welcome to episode 2 of our series entitled Math Teaser Alert, where we answer math questions that help sharpen your skills in critical thinking and problem solving. So, let's get into it. All right, so our question reads, n squared plus 45 is a perfect square. Solve for all n. All right, so I underline the things that we need. N squared plus 45 is a perfect square, and the phrase all. So we want to set up this equation where we're trying to find every single value for n that satisfies this condition where n squared plus 45 is a perfect square. So let's show you how to do it. So since n squared plus 45 is a perfect square, that we can set up algebraically and then go from there. So n squared plus 45 is a perfect square. So is means equals. Perfect square is anytime you take a number to the power of 2. That's what a square would be. So since we don't know what that number is, we can call that x and raise that to the power of 2. And that'll be our algebraic equation. N squared plus 45 equals x squared, hence a perfect square. So where do we go from here? Well, one thing you can do is to subtract n squared from both sides. And you end up with 45 equals x squared minus n squared. All right, so this is the result from subtracting n squared from both sides. What you notice is that this particular part of it here, x squared minus n squared, it's one of your special cases when it comes to factoring and foiling when you learn in Algebra 1 or Algebra 2, depending on which class. It's called a difference of squares. And when you have this scenario, we can reverse FOIL or factor it out in a more quote-unquote simple way. So the way to express that as a factored form is, so 45 is equal to x plus n and x minus n. So x plus n times x minus n is an example of FOIL. So you would perform FOIL on this, and when you do, it'll go back to this up here, x squared minus n squared. And that's how you know we did it right. But just take my word for it. All right, so x plus n times x minus n is equal to 45. Well, that part is helpful because what they're basically saying is that these two values in parentheses are just factors. Something times something is 45. So what we can do is just list the factors of 45. Actually, there aren't that many. Let me show you. So two numbers that multiply to 45 could be 1 times 45. It could also be 9 times 5. And it could also be 15 times 3. These three pairs, or these 6 numbers, can replace the parentheses up here and give you 45. So far so good. We're getting in the right direction. One thing you do need to know is that from this step here, let me do it up here. X plus n and x minus n, based on logic, if you ever take that as part of your geometry class sometimes, x plus n, that particular value, has to be bigger than x minus n. It's just a matter of simple logic, but if you don't understand it, just plug in numbers and see. If you take x and add a number to it, and then take that same x and subtract that same number from it, there's no way that this value can be bigger than that value. That just doesn't make any sense. 5 plus 8 versus 5 minus 8. 13 is bigger than negative 3. So that's what I'm trying to show. So this value has to be bigger than that value. Okay, cool. So we can use these 3 different pairs and substitute them in and see where we go from there. So for 1 and 45, so 45 has to be the value of x plus n, and 1 has to be the value of x minus n. So we can show that. So x plus n equals 45, and x minus n equals 1. We can literally just say that based on what we proved so far. And here, I would apply your rules for systems of equations because it's actually set up in that exact way. Since the question is asking for the value of n, what I would do is to see if I could solve that in this problem. So we'll solve for x first and then get n. It'll probably be a little easier to see what's actually going on. So the way to do that, I would get rid of n. So that means we have to combine these two equations. Let me get rid of this arrow sign. That way. So here, I would add these two. So x plus x is 2x. N plus negative n is just like saying n minus n. Anytime you add a negative number, it's just like subtraction. So n minus n disappears, and what you're left with is 45 plus 1, which is 46. And here it's simple algebra. You divide both sides by 2, and you get x is equal to 23. All right, and if you were to plug this number into one of the original x plus n or x minus n, let me do that down here. Let me plug it into the bottom one. So 23 minus n equals 1. So if you subtract 23 from both sides, you get negative n equals negative 22. And divide both sides by a negative 1, you get n is equal to 22. So there's one of our values of n. Solve for all n. We found one of them. One of them is 22. So far, so good? So now we just apply that same process to the other pairs of factors. We did 45 and 1. Now we can do 9 and 5. All right, so let me do that in a different color. I'll do it here. So x plus n for the quantity 9 and 5. 9 is bigger than 5, so x plus n has to be equal to 9. And x minus n has to be equal to 5. And then we just perform the same things we did before. Here we would add these two equations to each other. All right. X plus x is 2x. N minus n disappears. And 9 plus 5 is 14. Divide both sides by 2, and you get x is equal to 7. All right, so then you take x and you plug it into one of the two originals. We'll just use the same one we did before. So 7 minus n equals 5. Subtract 7 from both sides. You get negative n equals negative 2. And then divide both sides by a negative 1. You get n is equal to 2. So n equals 2 would be our second value for n. Again, but the solving for all n. So we use 1 and 45 to solve for that. We use 9 and 5 to solve for that. Now we have to do 15 and 3. All right, so we'll use the same process. I'll do that up here. So since 15 is bigger than 3, x plus n would have to be equal to 15, and x minus n would have to be equal to 3. All right, so like we did before, we're going to add these two equations to each other. So x plus x is equal to 2x, n minus n is gone, and 15 plus 3 is 18. All right, and 2x equals 18. You divide both sides by 2. You get x is equal to 9. All right, now we know the value of x. We can then plug it into one of the two originals. Again, we'll use the same one we did before. So 9 minus n equals 3. All right, and then you subtract 9 from both sides. You get negative n equals negative 6. Divide both sides by a negative 1. You get n equals 6. And that's our third value for n, so solving for all n. And since we've exhausted all of our options for the factors for 45, this is all of it here, 1 and 45, 9 and 5, 15 and 3. We've successfully found all values of n that satisfy this criteria, that not n squared plus 45 is a perfect square. All right, and there you have it, folks. There's a demonstration of Intelligent Black Society. I hope this lit a fire for your love and passion for learning in mathematics. Don't forget to like, share, comment, subscribe, and follow all of our social media pages, our Facebook, Instagram, and YouTube. And I will catch you guys in the next episode.